Hey everyone, my name is Noor and this is the second episode in the series Containers on the Cloud. Today we will talk about Docker images. I'm going to show you how to create, run and update your first Docker image. I'm also going to show you how to share that image so others can run it and see your awesome work. If you haven't seen the first episode yet or you want to refresh your memory about Docker concepts, please make sure to do so before continuing with this video. All you need for today is a machine with Docker and you are good to go. Let's get started. We learned last time that Docker images are used to store and ship applications. They are read-only templates used to build containers and defined in Docker files. An image is built up of a series of layers. Each layer represents an instruction in image Docker file. Let's examine a Docker file. This Docker file contains 4 commands, each of which creates a layer. The from statement starts out by creating a layer from Ubuntu image. We call this the base image. The copy statement adds some files from our Docker client's current directory. The run statement builds our application using the make command. I would like to highlight that run statements are executed within the image, not on our machine. Finally, the last statement specifies which command to run when we start the container. All layers except the very last one are read-only. Now that we have explored the basic syntax, let's create our own Docker file. First, let's create an empty folder for our project. I will call it n-flask and place it under my home directory. We then create a Docker file. Notice that it does not have any extensions. We start by defining the base image. We will create a simple Flask app which runs nicely under Python 3. So let's use that. From Python 3. I will use Alpine, which is a smaller version of the base image. In the second statement, we define our working directory on the image. Workdir app. The workdir statement sets the working directory for any run, copy, and command statements that follow it in the Docker file. Then we want to copy all the files from our project to the image. Copy everything. Copy statement takes 2 or more arguments: the source path on the host, which is relative to Docker file, and the destination path on the image. Note that such thing will not work. Copy. When building images, Docker client sends the build context to the Docker daemon. This is the default directory where Docker file resides. Copy statement can only access the file within the build context. Therefore, anything that was not sent cannot be copied. Moving on to the fourth statement, we want to install Python dependencies on the image by running pip install -r requirements.txt. Finally, we define the command that we want to run when we start the container. In our case, flask run. We may also pass the host 000, so it's listening on everything, on all the hosts, and the port as well. So it's listening on port 5000. Great, we have just created our first Docker file. Now let's go ahead and create the actual app. I obviously recommend that you create your app and test it first before Dockerizing it. I only did this for the sake of this video. By the way, you can find all the codes that I'm using in this video in a GitHub repository that I created especially for these tutorials. All the links are in the video description. I will create a simple Flask app. So we want app.py. And I will put this content in it. As you can see, it's a single endpoint on this. And also I want to create a requirements.txt. that has Flask and its last version, which is 1.0, I guess. Really good job from Flask team. Alright, we have our app, its requirements, and the Docker file. Let's first test that the app actually runs on our machine. Always try to run things in a simpler context whenever possible. This way you make sure you got the basics right before jumping into more complex situations. I call this progressive development, as opposed to progressive enhancement, which is often used in web design. To try the app, I will simply install the requirements and then run it. just like I did in the Docker file, but this time on my machine. I use pip-env to create virtual environment. You may skip that. And then pip install -r requirements, and then flask run. This should be enough, but let's pass the exact options that we use in the Docker file. So host 0000 and the port 5000. Great, it's running. Let's check the given URL. Yes, our Flask app is running and we are able to access it. Let's turn it off now. Now we can safely build an image out of our Docker file. To do that, we type docker build -f docker file -t the name and space flask and dot. The -t option allows us to name the resulted image so we can easily use it later. The dot at the end is the build context. The minus option tells Docker client where to find the Docker file relative to the build context, in case the Docker file is called something else other than the default name, which is Docker file. Since our Docker file has the default name and is located directly in the build context, we may omit this option and the build will run. So let's remove that. Now we see the build progress. It downloads the base image from Docker Hub library in case it doesn't exist on the host, and then execute the statements one after the other. Awesome, we have just created our first Docker image. Let's run Docker images. Notice that the image has the tag latest even though we haven't specified anything during the build time, except for the name. We will talk about tags in a minute. Let's run the image. Docker run to publish it on the port 5000, 5000 on the host, 5000 on the container, and then the image name. Oh, it seems we have some error. Let's check the Docker file again. I see, I should have replaced this with equal. So let's build again first. And then we should be able to run it. Looking good. Let's visit the URL. Perfect. Now that we have created our first image and ran it successfully, let's update our code and rebuild the image. I will simply append 2 to the welcome string and rebuild the image. Well, hello and space 2. Let me stop the first one. We can build it again. Let's run it and visit the URL. Great. In general, we use tags to represent changes in the image. As we have seen when we listed Docker images, each image has a tag. Tags help us version the image, similar to those used by Git, but not quite precisely, as they don't persist the change history rather than the state of the image by the time it was built. To specify a tag, we append column and the tag name to the image name when building and running images. When nothing is appended, Docker assumes that we want to use the latest tag, which points to the latest version of the image. Let's rebuild and rerun our image, but this time using tags. I will revert the changes I made to the welcome message. So let's bring this back and build again using the v1 tag. So this time I will build, however, I will append the v1 tag. Nice, and also run it. So docker run -p 5000 and space and v1. Great, it works. Now let's update the welcome message. and build using the v2 tag. Let's run it. Now it's running. We can also check it on the browser just to make sure. Good. We can actually run both versions of the image at the same time. We just need to publish them to a different port. I will run the containers in detached mode and assign them different ports and names. Docker run -b 5001 pointing to 5000 on the container. Detached mode, I will give it a name and call it ab1 or abv1 and use the v1 tag. It's running, and then docker, so basically the same thing. Use the v2, I will call this abv2 and point the 5002 port. To see what's running, we can docker ps. Looks good. Now let's check on the browser. If we go to localhost 5001, we have the first version of the image. And if we go to localhost 5002, we have the second version of the image. Now that we have created, ran and updated our first Docker image, let's share it with others. We mentioned in the previous episode that Docker images are hosted in Docker registries. For example, when we tried to run Nginx image last time, and since it did not exist on our machine, Docker Engine had to download it first from the registry. The default registry is called Docker Hub, where all the official images are stored. If you go to hub.docker.com, you can find an image for almost everything. It's also a great resource for development using Docker, as most of the images come with a great documentation on how to run and customize them. This is Docker Hub. Docker Hub account is free for as long as we want to use it for publishing public images. For private images, however, there is a monthly fee. If you don't have an account yet, please pause the video, create an account, and come back once you are done. After a fresh install, Docker client doesn't know about our Docker Hub account or any other registry. To change that, we need to open the terminal and Docker login. It normally asks us for a username and password, but since I'm logged in already, it didn't. If you haven't created an account yet, please do that and try again. Now that Docker client knows about our Docker Hub account, we can push images to it. We first need to tag the images so they contain our Docker Hub username. We can either rebuild the images and tag them with the name that has our Docker Hub username, like this. So Docker build, just the same thing, and instead of that, we add our Docker Hub username to the beginning, and then the repository name, and then the tag. Or we can easily tag the images that we just built, which is faster. Docker tag this image, the v1. I will tag it to my username, same repository name, and also the same tag. And then I will tag the second version as well. Now we can push these images using docker push Moshawish Flask. We can specify the tag to push, otherwise it will try to push the latest. But since we haven't created any latest version of this image, we should specify the tag. So I will specify v1. It takes a minute. I will also push v2. And it's done, almost. Yes, it's done. Let's check our Docker Hub account. So I logged in here. I will refresh the page and search for in space. Yes. So on the top, you read that this is a public repository, which means anyone can pull it using the command that we see to the right, this one. If we navigate to tags, we can see both v1 and v2 tags. Awesome. To verify that I can use the image somewhere else, I will SSH to another machine and try to pull the image and then run it. SSH T3. I will first run docker images so I am sure that I don't have the image. I will also run docker login to make sure that I am not logged in. And now the moment of truth. Let's try to docker pull Moshavish in space flask. Oh, I tried to pull the latest tag, which we haven't pushed. So let's try another tag. I will use the v1. Now it's working. Let's try to run it. Docker run sp 5000 Moshavish flask v1. It looks good. Let's navigate to the IP of the host. Good. So this IP 5000. Yes, it's working. Now let's try to run the second version of the image. Let's stop this one. As you can see, we can pull the image first, or we can also directly try to run it. It should auto pull it for us if necessary. It did not find the image locally, so it's pulling it from my repository and it's running it. Let's navigate to the browser. And we have the second version of the image running. Brilliant. Creating and running different images may quickly consume your storage. To delete unused images, tags, and containers, run the following. Docker system prone. It's asking us if we want to remove all the stop containers, unused networks, dangling images, and build cache. I will give yes. This way we reclaim some space. Like the last episode, I will attach a list of the commands we used today along with important resources and links for you to check out. Dockerfile has obviously more interesting commands. You can read about all of them in Dockerfile reference. I mean, just like anything when it comes to development, documents should be really your best friend with Google, Stack Overflow, and so on. You can also ask me anything about Docker images in the comment section below. I'm interested to know how you build images, publish them, and which registries do you use. You have just watched the second episode of Containers on the Cloud. If you enjoyed this video and found it helpful, please like and share. Also, don't forget to subscribe to the channel so you see more of these videos every week. I am Noor. Until next week, I wish you a great time. Ciao.